In this section, we will learn about the different types of pointers in C and C++ and how to declare them and how to use them. The goal of this section is to understand and master pointers in C and C++. So let's get started. Variables in memory. Let's assume we have three variables. A is an integer, F is a float, and C is a character. So let's see how these three variables are usually laid out by the compiler into memory. Just a reminder that the current platform settings we have for Windows and Visual C++, the integer type takes up 4 bytes, float takes 4 bytes, and then characters take 1 byte. For each character, there's 1 byte. So assuming the three variables we have, I'm just assuming like a compiler might place them in memory, something like this. The A variable is going to take up 4 bytes because it's an integer. So let's assume it's from 901 to 904. That's for A. C as a character takes up 1 byte, so let's assume it's at 9007. And finally, float is another 4 bytes, floating point number starting at 9009. So somehow the compiler will keep track of the fact that there are three variables, their types, and their memory locations. So when we start assigning values to, for example, a variable like A, if we say A equals 14, the value 14 is E in hexadecimal, and it's 1110 in binary. Remember that the data in memory is actually in binary. Alright, so when we assign 14 to A, it ends up having the value 14 stored in that memory location. So that's the relation between the variable names and the memory. So this is just an introduction to understand the relation between variables, memory, and pointers. If we actually print the address of A using the ampersand operator here, this is called the address of. If you say print the address of A, the result of this is going to be 9001. So you can actually use the printf function by using the address of operator. This will come handy when we talk about pointers. I just wanted to introduce you to the address of operator so that you are ready for the discussion on pointers. In this lecture, we will talk about the address of operator. So let's jump into Visual Studio and write some code. Okay, so here I am on Visual Studio. Let's create a new project by clicking on File, New, Project. Make sure you have Visual C++ and Win32 console applications selected. Let's call this one Pointers1. Click OK, click Next. In this page, make sure to select Empty Project, hit Finish. Right-click on Source Files, Add New Item. Let's call this one main.c. Okay, so today we want to talk about the address of operator. Okay, so let's assume we have three variables, A, F, and C. And now we want to see how we can print out their memory locations by using printf. Alright, in order to display memory addresses, we have to use the %p, stands for pointer. So this %p will show the memory address. So for example, in this printf statements, I want to display the value of A and also its memory address. So first I'm going to pass in A and then the address of A. Alright, so let's try this. Let's compile and run. Ctrl F5 to compile and run. As you can see here, A is equal 10 and its memory address, the address of A is equal to 0018F818. So keep in mind that this %p is actually printing out the hexadecimal value of the address. Let's try to do it in a different way. If we use just %d, for example. As you can see here, it's showing me that address in decimal. However, I'm getting some warning down here. It says maybe this is not your intent, but actually this is our intent. To display the same value as %p, we also can use %x. Let's try this. Now you can see it's pretty much the same. Just the formatting is a little bit different. Just to be clear, it's better to use the %p to print out the address. Okay, so also it's warning me about this. It's not a float, it's a double. Alright, let's continue with this. Print out. Just like we can print out the address of A, we can do the same for F and C. Alright, so let's give this a try. Ctrl F5 again. A is equal 10. C, every time I run, is going to be a different address. This time it's 0018F7A0. F is a float and its memory address is kind of very close to where A is in memory. Same for the character C. Its memory address is 18F7 8B. They're all very close to each other. Alright, so this is just a quick introduction on how to use the address of operator, and the address of operator is really important to use with pointers. In the next lecture we will start looking at how we can use pointers, define them and declare them, etc. See you in the next lecture. Why do we need pointers? In this lecture I will show you an example of why we need pointers in C, so that you can understand and appreciate pointers. Okay, so let's move to Visual Studio, write some code to see why we need pointers. Okay, so here I am on Visual Studio. I'm gonna create a new project. Click on the File, New, Project menu. Make sure you select Visual C++ 132 Console Application. Let's call this one Pointers 2. Click OK. On this page, just click Next. And now make sure you have the empty project option selected and then hit Finish. Okay, let's go ahead and create our first source file. Right click on Source Files, Add New Item, and then let's call it main.c. Okay, so today's lecture is about why we need pointers. Let's build an example together so that we understand why we need pointers. Let's say, for example, we want to swap two variables. How do we do that in C? Let's say we have integer a equals 10, integer b equals 20. Just a typical way to swap two variables is by using a third variable. So this is how you do a swap. And if you notice, every variable is going to show at least once on the left side, once on the right side. That's how you double check your swap code is correct. Okay, so now let's say we want to print this out. Okay, as you can see now, a is 20, b is 10. Okay, cool. So this is how we do swap. Now the next step is, let's turn this into a function. Let's call this function void swap. Takes an integer a and integer b. Just copy the code in here, and I'm gonna get rid of this code. And now let's call our function swap, give it a and b. Ctrl F5 to run. As you can see, a is still 10 and b is still 20. That's interesting. Even though here it actually is swapping the two variables, but why a is still 10 and b is still 20? We can actually verify. Let's set a breakpoint, F9 on my keyboard. Now I have a breakpoint on the swap function. Let's verify that we actually call it. Clicking on the green button here to start debugging. Okay, so now Visual Studio is waiting at this breakpoint. In order to step inside, I'm gonna use this step into, which is F11. If you step into the function, see it's gonna go inside. And now as you can see, if I hover on A, it's 10 and B is 20. So let's step into it. Now A is going to become 20 and B will become 10. When we leave this function, come back here, if we look again, oh, A is still 10 but B is still 20. Why is this happening this way? Well, because simply we're passing the A and B by value here. The swap function is taking integers by value, and that's the main reason why. When you actually call the swap function with A and B, the function here itself will have its own local variables called A and B. And they're not the same variables here. Let's verify the addresses here. So I'm going to print out the addresses for A and B. And then I'm going to do the same inside my function here, just to verify that this is not the same. This is main and this is going to be swap. Oh, so remember from the previous lecture we said let's use %b, not %d. Ctrl F5 to run. So now let's look at this. Main address of A is 1bf9cc. Whereas the swap address of A is 1bf8e8. It's not the same address. As you can tell from this, these are actually 4 variables, not 2 variables. And that's what is meant here by passing by value. So we actually swap them here successfully, but when we leave the function, the 2 variables are gone because these are local variables to this function. Alright, so that means one of two things. You can make your A and B global variables, right? Like this, and not pass them to the function, which is a very terrible implementation. Nobody wants to write code like that, of course. So just another thing to make sure that this is not confusing you. You can call the function parameters different names. They don't have to be exactly A and B. You can call them N1 and N2. Alright, so that means we can't actually do a successful swap this way. The only remaining solution to make swap work correctly is by using pointers, which is something we have to cover in the next lecture. So that's it for this lecture. In the next lecture, we will start to understand what a pointer is and how to use it and how to solve this problem using pointers. What is a pointer? A pointer is a variable that holds a memory address. Usually this address is for another variable of the same type as the pointer. For example, if the pointer is pointing to an integer variable, then it's called an integer pointer. I want you to understand that a pointer is just a variable in memory. It will take some memory space for its own, but the value inside it is going to be a memory address of another location in memory. How do you declare a pointer in C and C++? So as you can see in this example, I'm right now declaring an integer pointer. So P is a pointer to integer. You can read this from right to left, by the way, or you can say integer pointer P. Unfortunately, the C++ language did not introduce a new keyword for pointer, so they just use the asterisks. There are multiple styles for how you declare a pointer. One such style is to say the type followed by the star immediately, space the variable name. This style is actually encouraged by Bjarne Stroustrup, the inventor of C++, or you can declare it this way, integer space star P. They're the same for the compiler. In fact, if you put as many spaces as you want, the compiler is smart enough to understand that this is a pointer. This is just mainly for us to understand pointers and to stick to guidelines and coding conventions. I just encourage you to be consistent. And this is the third form that I just mentioned, which is you can do it this way. Pick the one that you feel most comfortable with and start getting used to a certain style. Okay, so now when we're declaring a pointer like this, it's considered to be uninitialized. This pointer is actually pointing to somewhere in memory. It could be inside the operating system code, could be inside some guarded memory, some place that you're not supposed to access. By accessing an initialized pointer, you might run into cases like crashing your program, causing some weird behavior to the system. So be aware of that. Modern compilers will warn you about this. So just keep in mind that you always have to initialize your pointers before you use them. So how do we make this pointer point to somewhere in memory? We use the address of operator. So we assign addresses to pointers by using the address of operator. Okay, so in this example, I'm going to show you how we declare an integer and a pointer to integer. If you remember from previous lectures, we said that the integer type takes up 4 bytes if we're on a 32-bit or a 64-bit system. The size on Windows is 4 bytes. The pointer, though, is usually going to be 4 bytes if it's 32-bit, or if you're on a 64-bit system, then it's going to be 8 bytes. And the reason for that is a pointer holds the memory address. In this example, I'm going to use 32-bit. An integer A is going to take up 4 bytes, for example, from 8001 to 8004. If we assign 14 to it, it's just going to hold the value here in this memory. Again, remember that this is in binary format, not in decimal. Decimal is just for us to understand. If we say print the address of A, you're going to get back the location of A in memory, which is 8001. Now let's declare a pointer to integer. So we say P is a pointer to integer, integer star P. The minute you declare a pointer, it's going to take up some memory space in here. Let's just assume it's very close to our A variable. So it's going to, for example, be at 8008. And since it's a 32-bit system, it's going to be a 4-byte pointer. And now it's not initialized yet. The minute we say P is equal to address of A, now we're going to assign the location of A to P, meaning that store here the location of A, which is 8001. With this statement here, P becomes initialized and it's now pointing to memory that we can access. This table here shows you what we have so far. We have a variable A of integer type holding the value 14 in its memory address at 8001. We also have a variable P of type integer pointer holding the value of 8001 at its location, which is 8008. I hope this is not confusing. You have to understand that since we have 2 variables here, then each variable is going to take its own memory, regardless of the type. You can just forget about the type now. You have 2 variables, each one will take up some memory space. That size of the space is determined by the type. If it's an integer, we can look at this table and say, okay, integers take 4 bytes. If it's a pointer, depending on which compilation you use, when you have a pointer, you look at this table and you say, am I compiling my code as 32-bit or as 64-bit? Remember that you have to be on a 64-bit system to be able to run code as 64-bit. So the nice thing about 64-bit operating system is that it can support both 32-bit and 64-bit. But if you're on a 32-bit system, you can still probably compile as 64-bit, but you won't be able to run it as 64-bit. So the recommendation is to always have a 64-bit operating system nowadays. And now you can test your code from Visual Studio. You can compile your code as either 64-bit or as 32-bit. In this example, I'm going to compile my code as 32-bit, so I'm going to assume that P is going to be 4 bytes, and that's what I'm using here. Alright, so now that we know that both of them have memory space, what is inside that memory? What's the data inside? For A, we assign it to be 14. For P, in this statement here, when we say P equals address of A, we assign to P the location of A in memory, which is this location, which is here also on the diagram. So that's its value. Now P itself lives in somewhere in memory to hold that value. You have to store that value somewhere, and that somewhere in this case is going to be 8008. So I hope this is clear so that you understand pointers. Okay, let's continue our discussion on pointers and variables. Again, I'm going to declare an integer A variable, assign to it 14. So this is an initialization declaration. You just immediately declare and initialize the variable. And in this case, it's going to be immediately taking up 4 bytes with 14. And now this is another declaration with initialization. So we declare an integer pointer P, and we assign to it immediately the address of A. This is a better way to declare initialized pointers so that you don't forget and leave it uninitialized. There will be cases that you cannot do it this way. I understand that. We will learn how to do that later on. Or you can initialize it to null, and that way you know that your pointer is not yet pointing to anything of interest to you. So let's move on. Once we say integer pointer B equals address of A, it gets the address of A in here. And when we say contents of P equals 15, so this is new. This is called dereferencing the pointer. So P is a reference to A. Contents of P is a dereference, meaning that the content of P is A. When you say content of P, the content of the memory address at P is going to be equal to 15. So this translates to assign 15 to the contents of this memory address. So this is the memory address, assign 15 here. Once our program executes the statement, what's happening is it's going to put 15 in the address that was pointed to by P, which is the address of A. So this is really just assigning 15 to A. So what I want you to understand here is that P is just the same as the address of A, because P is a pointer and the address of A is what you give to that pointer. Contents of P is the same as A. The contents of P is the value at that memory location, which is the same value of A. It can be used to read or write from A. So this is just a way to dereference the pointer to get to A. And now contents of P equals 15 is the same as A equals 15 based on this. Alright, so in the next lecture we will jump into Visual Studio to start using pointers and go over what we learned in this lecture. See you in the next lecture. Using pointers. Today we were gonna go over the stuff we learned in the previous lecture by writing some code in Visual Studio. So let's get started. Okay, so here I am in Visual Studio. I'm gonna create a new project. So click on File, New Project. From this window, make sure you select Visual C++ and Win32 console application. Let's call this one Pointers 3. Click OK. On this page, we will click Next. Okay, on this page, make sure you have the Empty Project option selected, then hit Finish. Let's right-click on Source Files, add New Item to add our first source file. Let's call it main.c and then click Add. Alright, so today we want to learn about using pointers in C, C++. So let's start off with an integer variable. Let's call integer A equals 14. Okay, let's define an integer pointer P equals address of A. Alright, so we have a pointer now that is pointing to A. Let's answer some questions, that way we can learn more. So where does A live in memory? Let's see that. Let's say printf. Remember that with %p we get the pointer. So this is how we print the address of A. Let's also print the address that is contained inside P. Let's just compare the two and see if they're equal or not. %P specifier in printf allows you to print the address. So that's what we're doing here. We're printing out the address of A. And then the next statement down, we're trying to print out the address contained inside P and compare the two together. So Ctrl F5. And now as you can see, address for A is 18FBB8. And the same address is inside P pointer. That means P is pointing to A. Cool. In fact, we can do this. If P equals address of A, say printf, P is pointing to A. Whenever you write an if statement, always think about the else case. What is going to be the else case? It's always a good practice to include the else case. Let's run this first. Ctrl F5. As you can see here, it says P is pointing to A. Cool. So let's clean this up a little bit because we want to move on to the next step. Right, so now we know where A lives in memory and that P is pointing to A. This time we're going to print out the values. And the way we print out the value of an integer is just by saying %d, the value of A. Now let's print out the value that's inside P. Okay, so I'm going to use %d and %x to print out the value of P as a pointer in both decimal and hexadecimal. If I hit Ctrl+Shift+B, I'm going to get two warnings down here that I'm using pointer with a %d, %x. That's my intent here, so I'm going to ignore the warnings. Ctrl F5 again to run. Okay, so let's look at this. Address for A is 18FE30. Address inside P is the same. A has the value 14. P has the value in hexadecimal is the same value as the address of A. That's the value of the pointer right now. Now, if we want to print out the contents of that pointer, that's the next step. So now the question is, what is the value at the address pointed to by P? Now let's print that out. Okay, so now we're going to say P points to an integer with value equals %P, and the way to get the value of that integer by saying contents of P. So by using contents of P, we're dereferencing the pointer so that we can peek at that memory location inside P and see what's there. So Ctrl F5 again. Let's run this. This time the address for A is 18FACC. A has the value 14. And now P points to an integer with value 14. That's the value at the memory location we were pointing at with a P pointer. Alright, so now let's do something interesting. Let's do contents of P equals 15. Let's change it. So we're going to change that pointer and let's print it out again. So Ctrl F5 to run. Let's look at this. So the last statement now, P points to an integer with value of 15. And we can actually print A value as well. And now as you can see, even A has the value 15 because pointer is just pointing to A and it's changing that memory location. So this time we're changing through A itself. It should also give us the same effect. Alright, so now P points to an integer with value 16. A has the value 16. So both of them can change the value. And that's how we use the pointers here. This was just a quick introduction to the pointers. And you might be asking how the pointer is useful. Well, it's probably not useful in this case. It's going to be more useful when we start passing values to functions and we don't have local access to them. Then pointers become handy and a way to access memory that is being passed to us somehow from some external source as a parameter to a function, getting it from some other place, etc. Right now, I just want to make sure that you understand the pointer, how to use it, how to initialize it, etc. Let's define integer b equals 100. I just want to show you here that we can actually now say p equals address of b instead of address of a. Copy this here, and then let's do the values as well. Okay, so let's look at this last section here. We're making p point to a new integer b, which is allowed. You can have the pointer points anywhere you want. And let's see this in action. Ctrl F5. Okay, so now as you can see, the last section, the address for b is 0018F9A4. Address inside p is the same one, so that means p is pointing to b now, not to a. b has the value 100. P points to an integer with value 100. So there you go. The p pointer is pointing now to a completely different integer. Alright, so I think that's it for pointers. I just wanted to make sure that you understand how to use them, how to initialize them, how to make them point to an integer, how to dereference a pointer, how to change the value being pointed at. You can do the exact same thing by changing the type from integer to, for example, char, character, or you can do float, or you can do any type you want. But that's it for now, and we will start using pointers more and more in future lectures. Using pointers with functions. Just to recap on what we learned in previous lectures, we discussed how to use pointers with variables. When we declare an integer variable like integer a and assign 14 to it, it will take up some space in memory, and then that value goes into that space. Since our integer is 4 bytes, it's going to take up 4 bytes of memory. Next, when we declare a pointer, integer pointer p, and give it the address of a, if our program is 32-bit, that means it uses memory addresses of 32-bit size. In that case, the pointers will need to hold addresses of 32-bit size, which is 4 bytes. However, if our program was compiled to be a 64-bit, in that case, the memory addresses that it can contain go up to 8 bytes. Then in that case, the pointer will be taking up 8 bytes of space to hold the longest memory address possible for a 64-bit. Alright, so once we say integer pointer p equals address of a, we actually make it point to a. And the way it does that, by holding the address of the memory location of a inside its own memory. So now the way the pointer p points to a is by holding that address inside it. Next, when we say contents of p equals 15, what we're trying to do here is indirectly access that memory that the p points to and change it. So by doing this, we say modify the integer value at the address inside our pointer. So this means contents of this memory address should change, make it 15. And as a result, the compiler will translate this into placing 15 in that memory address. So this is just a quick overview of what we learned in previous lectures. Today we want to see how to actually use the pointers with functions. So let's get started. Okay, so here I am on Visual Studio. Let's go ahead and create a new project. Click on File, New Project. Make sure you have C++, Win32 console application selected. Let's go ahead and call this one swap function. Click OK. Click Next on this page. And now let's select empty project so that we can create C program, not a C++. Click Finish. To add our C code file, we right click on Source Files and say Add New Item. I'm gonna call it main.c. Click Add. Okay, so in this lecture, we will learn about using pointers with functions. We will try to implement the swap function using pointers. In a previous lecture, we discussed how to swap two integers, and we tried to do it with a function, but we learned that swap cannot work correctly unless we pass pointers. And since we learned a lot about pointers, today is a good chance to go back and revisit that and try to implement the swap function again using pointers. Okay, so we had something similar to this where we have a swap function that takes two integers and then we assign a to a local temp variable, move the value of b into a, and then b becomes the old value in a by assigning the temp to it. And then we had something like this where we say this is a and b before swap. We do the swap and then we say this is a and b after the swap. So let's compile and run this before we start introducing pointers to make sure we still remember what's going on. Ctrl F5. So now as you can see here, it says a equals 10 and b equals 20 before swap. After swap, they're still the same. As you may remember, we said that the actual swap in here is valid. However, these are two local variables on the stack of this function. They're not the same as AB here. In fact, what we did was we did something here like we could print their addresses. So I'm gonna print their addresses once inside swap and once inside main to compare the two addresses and make sure that they're not the same. So as you can see here, inside main, the address of A is some value that if you look at the address of A inside swap is completely different. Same thing for B. So these are actually 4 variables in memory, not 2. So what happens if we start using pointers? The first thing we want to do is come here to the way we call the function. If we want to pass to this function the pointers of A and B, the way to do that is by passing their addresses. If we say address of A, address of P, right? That's how we should do it. That's where we pass to this function the pointer to A and a pointer to B. So that in here, the new variable that we create is a pointer that holds the address of the incoming variables here. Alright, since we have an address of A here, we know that from previous lectures that this can be only contained not inside an integer but inside the pointer, right? So we have to define this as a pointer so that it can satisfy this assignment, because this is going to be assigned to this variable here. In fact, if you just leave it like this, compile, Ctrl+Shift+B, you're going to get errors. As you can see here, integer differs in level of indirection from integer's pointer. So it's kind of telling you that there are different types. You have to use an integer pointer. Alright, so that's why we have to make this a pointer. As a convention, I like to have my pointer start with the word P. So I'd rather call it PA or P capital A or P1 than just calling it like we call integers. Let's call it PA. Then the same thing for this one, integer PB. Remember that this can be anywhere, right? To put the star next to the integer, space next to this variable, it doesn't matter. The compiler knows how to read it. For us, just as a convention, let's stick to the way we call it like this. Right, so now we have defined two pointers here, and let's say now we want to print out these 2 pointers, PA and PB. As you can see here, the code is actually now complaining because I got rid of A and B. I'm going to comment this out for a minute so that we can just compile and run. Ctrl F5. Let's zoom in and see. Okay, so now as you can see, inside main, address of A is 001AFD94. Inside swap, address of A is the same because that's the pointer. And the same thing for B. So now we're successfully passing the addresses into the function. So that's how you pass the address. That's how you receive the address here. Given the address, how do we modify the value at the address? That should be simple. Let's come here and modify this code. I'm going to uncomment it. So integer temp equals, we no longer have A, we have PA. You can't assign address to an integer. You should be assigning the value at that address to the integer. The way you read this is contents of the address, or however way you feel more comfortable saying that, give me the value at this address. Okay, so now what we want to do is we say PA equals PB. Now you got to be careful with this. The best way to learn is by doing things wrong first and then try to understand why this is not the right way to do it. So what I'm showing you here is why this is not right, because in this case, remember that PA and PB are variables. If you assign this variable to this variable, what you're saying here is that I want both PA and BB to point to the same memory location. In fact, this makes PA now hold the same address as BP, which is not what we want. We want to say the contents of the memory location at PA should be assigned the same value at the address at PB. So contents of PA equals contents of PP. This is integer assignment. However, the previous one, PA equals PB, address assignment. And finally, contents of PB equals temp. This is again placing an integer inside the memory at BB. To make sure this is correct, if you look at all 3 statements, each variable should show up once on the right side, once on the left side. Alright, so this is a valid swap operation. So now let's compile and run. Ctrl F5. Yes. Let's take a look here. Inside main, address of A is 18FA0C. Before swap, A equals 10 and B equals 20. Inside swap, address of A equals the same address as the one in the main function because it's a pointer. After swap, A now equals 20 and B equals 10. So now this is a valid swap function, and that's pretty much it. I will discuss pitfalls with pointers in a future lecture. For now, it's enough to understand how to successfully pass pointers into a function, receive them, and modify them. So that's it for this lecture. See you in the next lecture. Using pointers with functions. In this lecture, we will look at another example of how we pass pointers to functions and become more familiar with using pointers and functions. So let's switch to Visual Studio and get started. Let's go ahead and create a new project. Click on File, New, Project. Select Visual C++, then select Win32 console application. Let's call this one Get Min Max Function. Click OK. On this page, click Next. And make sure to click on empty project here, then hit finish. Right click on sources, add new item, and we're gonna call it as usual main.c, then click add to add the source file. In the previous lecture, we learned about how to use pointers with functions by implementing the swap function. In this lecture, we will also continue that discussion by implementing another function called getMinMax. So the idea here is that we want to implement a function called getMinMax. We give it an integer array of some values. It should return to us two variables, the max and the minimum. So the idea of today's function is we want to be able to provide the function with an integer array that has X amount of elements. So the count will specify how many elements in the array. And then we want this function to give us back the maximum element inside the array and the minimum element. We could implement this as two separate functions. One gets you the max, one gets you the minimum. But the whole point here is, what if you want to implement a function that gives you the two at the same time? You don't want to scan the array multiple times, while you can do it in a single for loop, right? And get the two maximum and minimum values. So let's take an example where we have an array here, just a random number of elements in the array. So let's say we have this array, and now we want to be able to define two variables, max and minimum. Now I want to call getMinMax, provide it with my array function, and give it its count of elements. In this case, I'm going to use size of array divided by size of array of 0, because that gives me the number of elements inside it. Or you can just make your life a lot easier by saying here count equals this, so you can verify you get the right count. And now we want to give it the max and the minimum. And lastly, we want to say printf, print out the max and minimum. If you have paid close attention in the previous lecture, you would immediately figure out that this is not going to work, right? This is not going to give us back the minimum and the maximum, because we are passing here by value, not by reference, which means that minimum and maximum inside main are not going to get back the values that we assign to max and min in here. If we say max 100, min 0, for example, if we run this right now as is, say Ctrl F5, run this, I'm getting some compilation errors here that these guys are not initialized. Let's assume we put in here 0 and in here 0. And let's say now this is how we implement the function. We will see that these values here are not going to be propagated back to the main function. Let's see that in action. Ctrl F5 to compile and run. As you can see, max is 0 and min is 0, because the values we assign here are not going to go back out to the caller. That's again, if you get the idea of pointers, that's why you need to pass by reference, which is a pointer. So typically, like I said, I'd like to have my pointer start as a convention with a P at the beginning, so it reminds me this is a pointer. And you can make the first letter after the P capital so that it's easier to read. Now in that case, what we do here, we say contents of Pmax equals 100, contents of Pmin equals -1. But still here we have to fix this, because this is passing by value, not by reference here. If we compile, Ctrl+Shift+B to compile, it should give us an error here. It's actually just a warning. What it's saying here is that integer pointer differs in levels of indirection from integer. So it's telling you that it's going to treat the value in here, the value 0, as a pointer. The correct thing to do is to assign the address of a variable to a pointer. So the receiving pointer should get the address of these variables. Now we can get back the values. So Ctrl F5 to compile and run. Now as you can see, the maximum of our array is 100 and minimum is -1. Cool. So this is pretty much all needed to work with pointers. However, we want to still implement this the correct way. So let's do that quickly. I will define two locals here, integer max and integer min. Gonna assign max to be the first element in our array. Same thing for minimum. They're both going to be equal to the first element. And then for integer I equals 0, I is less than count, plus I. Since we are already using the first element, it's okay to start from 1 here. And here at the end, we're going to assign max to this guy and minimum to this guy. So if a of I is greater than max, max equals a of I. Else if a of I is less than minimum, then minimum equals a of I. Just a simple comparison where always keep track of the maximum value here and always keep track of the minimum value. And then at the end, once we exit the loop, we assign the two local variables into the address assigned to the two pointers. So contents of, again, means dereference the pointer, go to that location, put this value inside that location. All right, so let's give this a try. Before we run this, our smallest value here, let me see which one is the smallest. Looks like -4 is the smallest here. And looking at this quickly, I think the largest value, the maximum is 50. So I'm guessing we're going to get 50 and -4. Let's see this in action. Control F5. As you can see, the maximum in our array is 50 and the minimum is -4. So that's it for how we can use pointers with functions. In this example, I wanted to show you how to use functions that require 2 pointers. You might run into cases where you need 2, 3 pointers, etc. If you know how to deal with 1 pointer, that means you can deal with multiple pointers, etc. The rules are the same. Make sure you understand the rules, and that should get you going. So that's it for this lecture. See you in the next lecture. Just to recap what we learned in the 2 lectures about pointers and functions. So first we learned about the meaning of passing by value, like this example where if we have a main function as an integer a and we pass that a into a foo function like this is passing by value, meaning that we will have 2 integer variables in memory as shown here. The first one that comes into memory is the integer one inside main. That's what I mean by here, main : a, just to say that this is the a inside main. It gets its own memory, and then when we call foo will also need another variable called a. It gets its own memory. So in this case, whatever you do inside foo is not going to impact the one in main because it's going to just work on this memory location here. So that's what is meant by passing by value. This is useful when you have already a value in a that you want to feed into foo, meaning that it's an input parameter. So this guy can read it and use it. If your function is going to change this value and expect it to go back to here, that's not going to work because it's by value. In that case, you would need to pass by reference. In C, the only way to pass by reference is through pointers. So let's look at the next one, which is what we learned also is passing by reference or by pointer. And let's look at this example. The same exact situation. We have a foo function. In this case, it's taken an integer pointer, PA, and then from within main, we define an integer and pass it on to foo by saying the address of a goes into foo. Here, eventually, foo is trying to dereference that address and put 100 in there. So let's see this in action. The first thing that happens is that main a gets allocated memory. Initially, it has garbage. Then we call foo and pass it the address of a. Immediately, once we call foo, it requires another variable, but this time this variable is a pointer variable. It will take 4 bytes because it's a 32-bit example. If it was a 64-bit example, I would draw 8 bytes here. So the next thing the compiler will do is will place this address of a into this location. So that's what it does. It knows how to put the address of a in here. In the 2 situations, we have 2 variables, but in this case, one of them is a pointer, whereas in the past case, they were both integer variables. Here, we have 1 integer, 1 pointer to integer. And now PA points to A. As long as you don't change how it points to, it's going to be always pointing to A. Once we enter the function, execute contents of PA, dereference the pointer, this means that go to the pointer, find the address, and go change its content. Inside that address 8003, I'm going to place 100, and that's what it does here. So this is the concept of pointer. If you get this, then you definitely understand pointers in C and C++. So that's it for now. See you in the next lecture. Let's create a new project. Click on File, New, Project. Make sure you have 132 console application selected. Let's call this one Pointers and Arrays. Click OK. On this page, click Next. And now let's make sure you have empty project selected, then hit Finish. Right click on Source Files, add New Item. And we're going to call this main.c. And click Add. Alright, in this lecture we want to talk about pointers and arrays. If we have an integer array a equals 1, 2, 3, 4, 5, 6, for example, let's assume we have this integer array that has 6 elements inside it. If you remember from previous lectures, the arrays in C and C++ are zero-based, meaning that we can say for integer I equals 0, I is less than 6 plus I. This is how we print out all the elements. So I, A of I. Let's run this, Control F5. And as you can see, we have from 0 to 5 all the elements we have in the array. Okay, so this is pretty much what we learned in previous lectures. Today what we want to learn is how the array is tied to pointers and how we can use pointers with arrays. The first thing we want to learn today is that the array name itself is actually a pointer. So this is the first thing you want to know, is that in C, C++, array names are pointers. So what does that mean? The array name is actually going to point to the first element in the array. So if we say printf %d and we come here and say contents of A, something like this. If we run this, as you can see down below, after the array it's printing out 1 because the name of the array is a pointer to the first element of the array. So that means that integer pointer p equals A is also valid. We use p here, we're going to get the same value. Alright, so now that we learned that the array name is a pointer to the first element, this is actually the same or the equivalent of address of A of 0. Let's do this. Let's run this one as well. You can see it's 1. If we say address of element of 1, then we're going to get the value 2 because that's the second element in the array. As you can see here down below, it's 2. We know now that the array name is a pointer to the first element in the array. So these are both equivalent. The other thing is that you can use a pointer to point to the array, and you can say either this one, let's do this, integer p1 equals A, and then p2 address of A of 0. If we try to print out p1 and p2 and also print out A itself, I'm going to show you that they're all equal. As you can see now, p1 is 0018 fd64, b2 is the same, and A is the same. So that means that the address of the first element is equivalent to the array name. Array name is pointing to the first element of the array, and you can assign that to pointers. So now that we assign it to pointers, how useful is that? There's many things we can do with the pointers and arrays, and that's going to be a discussion for the next lecture when we talk about pointer arithmetic, where we can actually increment and decrement pointers and see how we can do that. For this introduction, I just want you to know that the array name is a pointer and it points to the first element in that array. Let's also look at character arrays. If I have character s like this equals hello, in this case we are using a string. S is a string. Also, s is a pointer to the first character in the array. That means that character pointer p equals s is going to also be a similar thing. S is a pointer to the first element in the array. And we can say printf %c contents of p. That should print the first character, which is h, because %c is 4 characters, and contents of p, it's a character pointer. It should point to the first character. Let's see that as well. Control F5. You can see here h is the printout. Similarly, if I do contents of s, it should give me the first character in s, which is h again. You can see. And also we can say contents of address of s of 0. As you have guessed from previous lectures that the contents and address, they null each other out. So this could be even s of 0, but let's do it this way first and see that in action. As you can see now, it's h again. And lastly, this is just exactly the same as saying s of 0, because we're printing out a character here. See, it's the same thing. We will discuss more about arrays and pointers in future lectures. So that's it for this lecture. See you in the next lecture. Okay, here I am on Visual Studio. Let's create a new project. File, new project. 132 console application. Let's call this one Pointer Arithmetic. Click OK. Click Next. And then click on Empty Project and then hit Finish. Right click on Source Files, Add New Item. Let's call this one main.c. In this lecture, we will learn about pointer arithmetic. Pointer arithmetic stands for incrementing and decrementing pointers. You can do some arithmetic with pointers where you can add to a pointer or subtract from a pointer, effectively changing the address in memory that it points to. Let's see that in action. Let's first start with an array. Say we have an integer array equals 1, 2, 3, 4, 5, 6, 7, etc. And now let's say we have an integer pointer p equals a. We learned from previous lecture that the name of the array is also a pointer to the first element. So I can say here printf %d, and I can say content of p. This should give me number 1. Well, what if I say p++? What's going to happen here? In this case, this is an example where we do pointer arithmetic. Advance p by 1. When you do something like this or something like this, p equals p plus 1, in this case, we are moving the pointer 1 integer ahead, not 1 byte. What does that mean? 1 here means 1 times size of integer bytes. In this case, equals 4 bytes. Let me just get rid of this. If you want to be more generic, you can say this is 1 times size of contents of pointer in bytes. Okay, so let's see this in action. This should actually print out 2. Ctrl F5, run. As you can see now it's 2. If I here come back and say p equals p plus 2, remember that p is assigned to initially a, which is this location here. If we say plus 2, that means advance from this location 2 locations. So 1, 2, it should give us 3. You can see now it's 3. Okay, cool. So that's how pointer arithmetic works. Let's see another example. If we say p equals address of the element 6. If I say minus 2, then that's also pointer arithmetic. In this case, I'm going to tell my pointer to move 2 integers back. Our pointer is here. It's going to go back by 1, 2. So let's see this in action. Ctrl F5. As you can see now, it's printing out 5. Okay, cool. The last thing I want to mention here is that most people do something like this. P minus equals 2 instead of this form. And the other thing that people most of the time do is p plus plus or p minus minus, etc. So make sure that you use the form that most people use. There's also plus plus p and minus minus p. The prefix or the postfix notation, depending on the situation that you have. All right, so let's now write a function that says void print integers, and we give it an integer pointer p and integer count. Using the pointer arithmetic, we want to print out the integers. Let's get rid of this here and get this guy here. What I'm going to do is for integer I equals 0, I is less than count, plus I, print the contents of p, and then p plus plus. And now here, let's say p equals a, and we're going to say print integers p, or actually let's just use a because we know a is a pointer. Print out the first 3. So what this function here is doing is saying that take this integer pointer, print out the first 3. So let's see this in action. Ctrl F5. As you can see now, it's printing out 1, 2, 3. Cool. If we actually give it the address of something in the middle, a of say 4, well, a of 4 is going to be too far, so let's choose this 2, then run this. Now as you can see, it's printing out 5 and 6 because the address of a of 4 is this guy and then print it out, continues to the next integer. So this is moving integers 4 bytes each time, because the size of integer is 4 bytes. You gotta be careful with this, because like I said, let's say if I say here 10, for example, let's run this. You can see I'm printing out some garbage after the last element here. So you gotta be careful with this and make sure you know what to pass to functions like this. The other thing is that if somebody here comes in and pass you a null pointer, for example, null in here, in that case, our code here doesn't actually guard itself against null, right? So if we do that, we're gonna get a problem. See, now our program has crashed, stopped working, and let's close the program, because we're dereferencing a null pointer, which is something we shouldn't do. We should always here check if null is p, then we can say return. That's one way to do it. Another way to do it is to say if p is not null, then you can do something like this. What I really like about this first approach, and it's more recommended, that's my recommendation, is because with this approach, if you keep doing this and you always have to check if something, and you see like the code keeps going indented inside based on the checks you have. I've seen in the past many lines of code like a zigzag goes all the way in, and then you have curly braces going back. I don't really like this approach. If you can avoid it, this is one way to avoid it, right? Don't do it like this. Just do it the first way. That way you don't have to make your code hard to read. Just do it this way, right? Check for null. If it's null, return. If you return something other than void, you can return an error code saying you're passing me a wrong value, etc. So this way we are going to protect ourselves against a null pointer. Okay, so that's pretty much it for pointer arithmetic. Here I am in Visual Studio. We're still discussing pointer arithmetic. So let's open up the project from previous lecture called pointerarithmetic.sln. So this is what we did in the previous lecture. Let's see now how we can print out the address of the element as well as the element itself, the integer, so that we can compare and notice that the addresses are moving by 4 bytes and also that they're actually sequential. If we want to print out p itself, we normally use %p for the pointer, but that's going to be hexadecimal. So to show you that in decimal, it's easier for us to compare decimals. I'm going to just do a %t here and then print it out as an integer here. Can typecast it to an integer. We can just say contents of this equals this. Oh, we need to fix this here. A, and then let's say print out 6 elements. Control F5. As you can see now, it's printing out the integers from 1 to 6 on these memory locations. Notice that they're all sequential, and the first one starts at 4, 0. The second one is at 4, 4, because this is, again, like I said, is an integer increment, right? The one pointer increment is causing it to move 4 bytes. Then from 4 to 8, from 48 to 52 to 56 to 60. So that explains how the pointer arithmetic is incrementing the pointer by 4 each time here. In the next lecture, we'll do the same exercise, but using character arithmetic instead of integer arithmetic to show you the same effect with characters. You will notice that the character increment is not going to be 4 bytes, it's going to be 1 byte. So see you in the next lecture. Okay, we're still discussing pointer arithmetic. Let's go back and open up the project from previous lecture, which is called pointerarithmetic.sln. Open it up. As you remember from previous lecture, we discussed printing integers using a pointer. In this lecture, I want to show you what if this was a character array instead of an integer array. And we'd say we have something like hello world or anything else. We want to change it slightly so that it can print chars instead of integers. So this is going to be a char pointer. In this case, we can say C %p p++ moving char 1 byte each time. Character size is 1 byte each time. So if we were to do this, if we said from as print the first 5 characters, for example, then this code here is going to take character pointer, print out this many characters that we specify. Okay, so now we have this print chars. We feed it our string s, and then we say we want to print only 5, and it's going to start from this pointer, which points to the first character, because the name of the array points to the first character. Let's see this in action. Ctrl F5 and run. So you can see now it's printing HELLO. Cool. It can even do the same if we say print from, let's say, position 7. Run this. As you can see now, world is being printed out because it starts with this location here. All right, so that's how we use pointers with characters and character pointers. I will have a section on strings and pointers with strings in future lectures, but right now I just wanted to introduce pointer arithmetic with characters and making sure that you understand that this plus plus is doing 1 byte at a time, not the same case as integer where it was doing 4 bytes at a time. Because depending on the type, this moves based on the size of the elements of what it's pointing to. Okay, so here I am on Visual Studio. I'm going to create a new project. File, new, project. Make sure you have C++ and 132 console application selected. Let's call this one pointers and strings. Click next on this page. On this one, select the empty project and then hit finish. Right click on source files, add new item. Let's call this one main.c. Add. In today's lecture, we want to learn about how we use pointers and strings together. Let's define a string array. Let's call this one str1 equals hello. Then we want to define a character pointer p equals also hello and show you the difference between the two. We said before that both p and str1 are pointers, pointing to two different locations in memory. Let's find out the two addresses. Let's compile and run. As you can see now, they are actually pointing to different locations in memory. This one here is actually a little bit different than this one. str1, we're allowed to do something like this. For example, change the first letter to W instead of H. Let me print out the two. This location str1 equals %s. We use %s for strings with a printf, and p equals %s as well. So let's print out both str1 and p. And let's just comment this out for now. Okay, Ctrl F5 to compile and run. So now you can see str1 is at this location and p at a different location. str1 equals hello and p equals hello. Let's go ahead and try and change the first letter for str1. This should be fine. We're allowed to do that because this is actually an array variable that is allocated somewhere on the stack, and we can change all the values inside it. However, this array size is fixed size. It's only big enough to hold all these characters plus one additional null character at the end. So it's going to be 1, 2, 3, 4, 5 plus 1, which is 6. Total of 6 elements in here. This one is pointing to somewhere in memory where this is going to be read-only memory. Because it's constant, the pointer here is pointing to that memory. The compiler will put this somewhere inside some memory section that we're only allowed to read from it. And that's the main difference. You can do this, it should be fine. If we run now, as you can see now, str1 equals hello instead of hello. Let's do the same thing with the p pointer. If we say p of 0 equals w, which is the same as saying content of p equals also w, either one is fine. Let's try them one by one. Let's try the first one here. Let's compile and run. See, now my program has crashed because we caused the problem. The operating system actually prevented us from causing a problem by modifying read-only memory. That memory is being protected and we're not allowed to change it. You cannot do this. Okay, if somebody thinks that it's because of the notation, okay, let's try it this way. It should be just exactly the same. They're both the same. Let's try it now. Ctrl F5. You get the same problem. As you can see, your program has stopped working. It was stopped because it's trying to access memory it's not allowed to access. So the takeaway from this is that you can allocate string like this in some section that's considered to be read-only, and you can point to it and use it for read-only stuff, but you cannot change it. Whereas in this one here, you're actually allocating memory on the stack of 6 elements in size that you can modify it, but the other one you cannot modify. So this is very important to know, understand the difference between the two. Alright, so that's it for this lecture. In the next lecture, let's see an example of how we can modify a string in a function and given a string, remove all the vowels from the string, etc. So let's do that in the next lecture. In the previous lecture, we discussed how to print the vowels of a string. In this lecture, we're going to talk about how to remove vowels from a given string using pointers. So let's get started. Okay, just to show you how we want to implement the remove vowels, let's assume we have a string str that has the word hello in it. So to implement remove vowels, we will pass the string into the function, and then inside the function we could use two pointers. The first one, called psource or whatever name you want to call it, points to the input string. So it goes from the beginning all the way to the end until we come across the null termination character. At the same time, we will have a b destination. Let's assume for now it's pointing to some output buffer. The first thing we should do as we start looping through the string is look at each character. If this is not a vowel, then we copy it over to the destination. In this case, h is not a vowel, so we copy it to b destination. Then we advance the destination pointer, and also the source pointer goes to the next character. Now the next character here is e, which is a vowel. Then we simply just advance the source pointer and not the destination, because we're not going to copy that. Now we come to L, we find, okay, this is a non-vowel. Copy it over to destination, advance destination, and also advance the source. Copy also L again, and advance two pointers. Now O is another vowel, skip that. P source is now pointing to the end of the string, so we exit out of the loop. But we should also null terminate the output string, otherwise you're not going to be able to know the length of the string. If you do not null terminate your string, then you're not going to be able to use it with any of the string functions. Also, you won't be able to treat it as a real string, because strings in C++ should be null terminated. Okay, so before we write the code, the last thing I want to mention is that we really don't need a destination buffer. We could just have the destination pointer point to the same string with the same logic, and we can do this whole thing in place. So let's see that in action in Visual Studio. Okay, so here I am on Visual Studio. Let's go ahead and open up the project from previous lecture called pointers and strings, so we can start implementing the remove vowels function as we discussed. We have the function remove vowels with a character pointer p, so we could use that. Let's define a character pointer b destination equals p. They both point to the beginning of the string. While contents of p, meaning that while we're not at the null character, remember that this is always true unless you come across the null character, which is value is 0. If you remember, in C and C++, any expression evaluates to true if it's not 0. So in this case, we can safely say, while the contents of P is anything but 0, continue. Of course, we have to say P++ here. My recommendation is always to think of writing your loops like this: the termination condition, and making sure that you always advance the pointer. Otherwise, if you forget this, then you're going to be in an infinite loop. Alright, so now what we're going to say is, if not this vowel, contents of P destination equals contents of P, and then P destination, we should advance it to the next location. We can combine the two together into a single operation and just do it like this. This way, the code is just more compact. And lastly, we have to say contents of p dest equals the null character. I recommend you do it this way. Some people might do it this way, equals 0. This way, it's more portable than the 0 value. The compiler will figure out the value of this, whether it's ASCII, Unicode, whatever. So I recommend you do it this way. Okay, so this is the function here. The only thing we don't do here, we don't check for null. We've learned about that in a previous lecture, so we should be fine. So let's say we have a character string equals hello world. Here we can say remove vowels from our str printf. We use %s with printf to print strings. So this means we can pass the string here and we're done. Okay, so let's give this a try. Control F5, compile and run. So as you can see now, the first function prints only the vowels. The second function gives you a string back that it rips out all the vowels from that string. Okay, so that's it for this lecture. The last thing I want to emphasize one more time is that if you do hello here like this, you gotta be careful. You cannot pass this into a function like this because it's actually modifying that string. I've discussed this before, that this is a read-only string. You cannot modify it. You can only print it out. You can read it, but you cannot write to this location. So don't do something like that. In fact, we will learn in the next lecture about using const pointers and how const keyword helps avoid things of this nature. Alright, we're still discussing pointer arithmetic. Let's go ahead and create a new project. File, new project. Make sure you have C++ and Win32 console application selected. Let's call this one pointer arithmetic 2. Click OK. Click next and make sure you select empty project from here, then hit finish. Let's go ahead and add our source file. Right click on source files, add new item, and let's call it main.c. Click add. So let's say we have an integer array that has few integers inside, something like this, and then define a pointer that points to the same array. And we said before that the array name is a pointer to the first element. That's why this is acceptable in C and C++, where you can assign pointers to each other. So now both of them are pointing at the same information in memory. Right, so today I want to show you how you can actually use the array name itself, just like you use the pointer, with the following idea where you can say a plus 2 as a pointer and say contents of that pointer. So what this means is that this is exactly the same equivalent of saying a of 2. So let's try it out this way. Ctrl F5 to run. As you can see now, it's printing out 3 because 0, 1, this is the element at 2. The other thing I want you to see, which is that this is also equivalent to doing the following. If we copy this here and make this p of 2 like this is going to give us the same information. Let's actually do all 3 possible ways of doing it. A of 2, contents of a plus 2, p of 2, and then the last one that kind of maybe along the same line, contents of p plus 2. Alright, let's run this before we discuss it. Ctrl F5. Now, as you can see, they're all printing the same value. What I want you to learn and understand today is that the array name can be used this way, where we're using the index notation, or it can be used as a pointer like this, contents of the pointer, because the address can be used with an arithmetic operation. So this means that move the pointer 2 integers ahead in memory. That's why it goes from location here 0, 1, and 2, and prints out 3. Same thing we can do with the array, we can do with the pointer we just assigned here. In this case, it's the same as saying the one below, give me the integer at offset 2 from this address. Same as this one, contents of p plus 2 as the integer at this address, which is the address starting from here plus 2. So if this was characters, then the offsets will be, instead of 4 bytes, will be just 1 byte, because the character size is 1 byte, the integer size is 4 bytes. So that's it for this lecture. I hope this clarifies some of the pointer arithmetic stuff. Make sure you actually do it yourself. Take the time to maybe write a function that goes over all the elements using a pointer, print them all out, etc. Okay, so that's it for now. See you in the next lecture. Okay, so here I am on Visual Studio. Let's go ahead and create a new project. Click File, New Project. Make sure you have C++ and Win32 console application selected. Let's call this one pointers and const keyword. Click OK. On this page, click Next. And here we want to make sure that empty project is selected, then hit Finish. Right click on source files, add new item, and let's call it main.c, enter. Okay, so today's lecture is about pointers and const keyword in C and C++. So let's start with some example. Okay, so let's assume we have an integer a equals 100. To define a pointer that points to a, we simply say integer pointer pa equals address of a. Now, let's introduce the const keyword. There are cases where you want the integer you're pointing to be constant, meaning that you don't want the pointer to change the constant. In that case, you can say constant integer pointer pc equals address of a. C++ allows you to do this. It also allows you to do something like this. Integer const pointer pc2 equals address of a. You can also say integer pointer const pp equals address of a. Well, that's not over yet. You can now say const integer pointer const ppc, let's call it address of a. And of course, you can also do integer const pointer const ppc2 equals address of a. Alright, so as you can see, this is how many variations we can do. Let's take them one by one so we can understand what we're doing here. The first and most important tip that I want to teach you today is that whenever you look at this, you simply read it backwards. You start from the right side all the way to the left side. If you read it as const integer pointer PC, you might get confused. But if you say PC is a pointer to an integer that is constant, now this makes more sense. Now you can say PC is a pointer that points to a constant integer. That's how you read it, right to left. If you get this rule, then you're not going to be confused by this. The second one here, PC2, is a pointer to a constant integer. In fact, this and this, I just wanted to show you that these are exactly the same. The C++ compiler is not going to differentiate between the two. So just pick one that you feel most comfortable with and make sure that you're consistent and use it all the time. So integer constant pointer PC2. PC2 is a pointer to an integer that is constant. All right, so now you should guess this yourself before I say it. PP is a const pointer to an integer. This one here, PPC, is a const pointer to an integer that is constant. PPC is a constant pointer pointing to a const integer. And the last one is just the same. PPC2 is the same as PPC. Again, like I said, this is a matter of preference if you want to put the const keyword first or the integer keyword first. Same as PPC. So now what does this all mean? Let's take them one by one. First of all, I want to introduce a second integer here, b equals 200. All right, so here PA is a pointer to integer. Let's start with PA. Using PA, we have no limitations. First thing, PA can change the value of the integer it points to. And secondly, PA can point to a totally different integer. There's two things you can do with a pointer. You can change the content of the variable it points to, and you can make it point to a different location in memory. So the first one means like we can do this content of PA equals, for example, instead of 100, 101. The second one means that PA can now point to B instead of A. Okay, so that's the first pointer. Let's take PC. What does PC mean? Which is a pointer to constant integer. It can point to any integer. PC cannot modify or change the value inside the integer it points to. So meaning that content of PC equals 10, for example. As you can see, I have a red squiggly here saying that expression must be a modifiable L value. If I try to compile Ctrl+Shift+B, I'm gonna get an error here. L value specifies const object. That means it cannot change it. So you cannot do this. Secondly, PC can point to another integer. PC equals address of P is completely valid. The const integer pointer cannot modify the value, but it can point to another integer. Okay, so the third type down the list, these two are the same. So the next one down is this one, integer pointer const pp. In this case, a const pointer to an integer. What are the rules for this one? One, the pointer is constant, but the integer is not. That means the integer value can be modified. So meaning that contents of pp equals 102, for example, this should be fine. The second one is not fine, however. The pointer cannot point to anything else in memory. So that means it's a constant pointer. This pointer is always pointing to the same variable. There might be some cases where you need this. In my 20 plus years of programming, I haven't had a chance to use it. I'm sure there are some scenarios. I haven't covered all scenarios, and that's why it's there. But just to give you an idea, this is something that you don't come across very often. Okay, so we said it cannot point to something else, meaning that if I say pp equals address of b, this should give me an error. So you can see here, without compiling, compiler knows that it's a const pointer to an integer, that it cannot point to anything else. Even if you say address of a again, it's not going to allow you. Basically, the minute you try to give it a new address, this is where the compiler will give you an error. It cannot be assigned any memory address. It can only be assigned once here at definition. So a const pointer must be initialized right away. You can't say integer pointer const p test and then expect yourself to give it a value later on. You can't even do this. You have to give it the address right the minute you define it. this is not going to compile. All right, so moving on to the next one, which is the last one. One of these two is the same. Let's take just this one. This is like the one that uses constant on both sides. And lastly, this one, constant integer pointer const. So in this case, a pointer that is const, which also points to const integer. This is the most extreme case, meaning you can't change the value, you can't change the pointer address, you cannot modify the integer or point to another integer. For example, I say contents of ppc equals 103, I'm gonna get an error. See here, it's not allowing me to do that. If I even say ppc now equals address of b, that's also gonna be an error. So basically this is just in some cases where you have a special value that is constant and you have it in a special pointer that you want to pass to a function, then you use the constant pointer that points to a constant integer. So that's it for this lecture. I know we didn't write a lot of code, but there's only one rule, one important rule, that if you read it right to left, you will not get confused. You say PC is a pointer to an integer that is constant. PC2 is a pointer to a constant integer. PP is a const pointer to an integer. PPC is a const pointer to an integer that's const. PPC2 is a const pointer to a const integer. These both are the same. These are all the cases of const and pointer coming together. We're going to revisit this in future lectures. In order to master this, you need to sit down with the compiler, write the code, play with it, print out the results, compile it, understand how it works, try to break it. That's the best way you can learn it and master it yourself. So that's it for now. See you in the next lecture. Today's lecture is about void pointers. So let's get started. Alright, so here I am on Visual Studio. Let's go ahead and create a new project, File, New Project. Make sure you have C++ and 132 console application selected. Let's call this one Void Pointers. Click OK. On this page, click Next. On this page, we want to select Empty Project and then hit Finish. Right-click Source Files, Add New Item, and let's call this main.c. Then hit Add. Okay, in today's lecture, we're going to learn about a new type of pointer called the void pointer. So in C++, a void pointer has no specific data type, so it can be used to point to any data type. Let me explain in examples. If I have a void pointer here, p, let me just use some variables first. Integer a equals 100, char c equals h, float pi equals 3.14 float. Let's say I have a pointer for each type. If I have an integer pointer pa equals address of a, char pointer pc equals address of c, float pointer ppi equals address of pi. Okay, let's assume we have a void pointer p. We can simply, given that void pointer is not tied to any specific data type, that means it can point to any type you want. So you can say p equals pa, for example, which is the same as saying p equals address of a. But now p is a void pointer pointing to integer. You can also say p equals address of c. So as you can see, you can assign pretty much anything to p. P can point to any type. This can be very useful in certain situations and cases where you have a generic pointer. So think of void pointer as a generic pointer. Another name for it is like generic pointers. The term generic here means that p basically can point to anything. Let's see how we can make use of this by using a function here. Let's create a function here called void print value by passing in a void pointer p and then an integer type. We're going to define this type as an enum. Let's call it, for example, value type. It can be char, integer, float, string, for example. So instead of passing an integer, we're going to pass in a enum value type. Do a switch on that type. So let's assume that somebody's calling this function with a void pointer p and some value type. If that type is a char type, in that case, we're going to print it out as the following. And then we can say contents of p here. Notice that this is where the void pointer is different from a regular pointer. Squiggly is saying incomplete type is not allowed because this is not complete type. It doesn't know what it's pointing to. So you have to actually cast this to a char pointer. In order to tell the compiler to treat this as a char pointer, we say char pointer p and then take the contents of that. Dereference the char pointer p. If this is not clear to you, another way to do this is simply by declaring a local variable here. I'm just using a curly brace so I can define a new variable here. Char pointer pc equals char pointer p. So I'm converting void pointer into a char pointer by using the typecast. And then I say dereference the pointer to char, which is really the same as the void pointer. So this is one way to do it. However, I don't want to do this. I'm going to do inline typecasting for the other types. Let's leave it like this for this example. Now the next example, I'm going to just copy this here. If we're given an integer, I'm just going to say contents of p, and we know that p is a void pointer, is going to give me an error. Just going to say integer pointer p, contents of that. So dereference the integer pointer p. So typecast it to integer pointer, then give me the content. In this case, this should be %d, and I should make this integer. Okay, let's copy this again here. Float %f, and this is going to be float pointer. And finally here we say string, %s for strings, and we're going to say just make it a string pointer. A char pointer is a string pointer in C, C++. Now lastly, let's assume somebody passes an invalid type or a new type has been added. Then by default we can say here unexpected. So that way we can tell the caller that this is something we did not expect. You probably added some new value here that we need to address, or somebody is trying to pass in an integer like -1 or whatever. That's not part of the whole switch. Okay, I'm gonna actually just make this one like this to make it clear. All right, so this is pretty much how we want this function to look like. So what we did is we defined a new enum type that handles char, integer, float, and string. A parent value is a function that's going to take a void pointer, and it will actually print out each type depending on the pointer. Let's give it a try here. Say print value, and now we can say address of A, and this is going to be integer. Copy it. Address of C, this is char. Since here we have a pointer to a float, I could either pass this into my function or just use this guy. So I'm going to use this guy in this case and make sure that this is float. And last but not least, to test the string type as well, I'm going to use this is a string used with void. And we have to call this a string. And that's pretty much it. So what we're doing here, we're actually printing out an integer using a void pointer function. Then we're printing out a character, we're printing out a float and a string. This is an example how to use void pointers, where you're given one function that can deal with integers, characters, floats, and strings, etc. So let's give it a try. Ctrl F5 to compile and run. Yes, as you can see here, the integer value is the first one that we passed in, is 100. The character is h. The float was the pi value, and the string was hi. This is a string used with void pointer. So this is pretty much it for void pointers. So the takeaway from this lecture is that void pointers are generic pointers, so they can be used to convert between any pointer type into void and vice versa. Remember that in the process, typecasting is involved. The compiler knows nothing about the void pointer. It doesn't know its type, its size. Okay, so that's it for now. See you in the next lecture.